Hello everyone, thank you for being here. My name is Alex Martire. I'm a professor of archaeology at the Federal University of Rio Grande in Brazil. I present here together with my colleague André Zarankin, professor of archaeology at Federal University of Minas Gerais. He coordinates LEACH and the White Landscapes project. In this talk, I show how we use digital technologies in Antarctic archaeology. I speak about LiDAR and photogrammetry, about 3D printing, about virtual realities and game engines, and about our databases. These tools help us to care for research, protect very fragile places, and also speak with the public in a clear way. Many people imagine that Antarctica is empty and without history. This is not true. For 2 centuries there are activities on the continent: sealing, whaling, exploration, science, logistics, and also tourism. All of this leaves material traces: shelters, depots, stations, caves, graves, and everyday objects. Our project asks simple questions: who used these places? How did they live and work there? And what choice did they make? We look for alternative narratives. We move beyond heroic stories. We show the daily work of many people and different nationalities. Digital methods help us measure, compare, and explain these treasures. They also help us share them with people who will never visit Antarctica. Our work uses 5 main tools. First, 3D capture. We use terrestrial laser scanning or LiDAR for precise geometry, and photogrammetry for color models of sites and objects. Second, virtual reality and game engines. We build simple, stable scenes that run well on common headsets. Third, 3D printing. We print scaled parts of sites and artifacts so people can hold them and learn by touch. Fourth, video and small exhibitions. We create short, clear videos and sensorial displays. Fifth, databases on the web. We store data with good metadata and publish selected models online. All these parts connect in one pipeline, from fieldwork to the public. Antarctic sites are remote and fragile. With LiDAR and photogrammetry, we create accurate digital copies. We can measure them many times without touching the site. Data about Antarctica is often separate in different places. Our databases bring notes, photos, models, and documents together. Many stories focus only on firsts and on famous explorers. Our digital media shows daily labor, repairs, supply chains, and cooperation. Most people cannot go to the Antarctica. Web models, VR, and 3D prints give access to students, teachers, and museums visitors. In this way, one dataset supports research, conservation, education, and dialogue. Our workflow has 5 steps. Capture, we plane scan positions, record with the LiDAR, take GNSS points, and make high overlap photos when needed. We also write context notes about materials, damage, and weather. Processing, we register scans, clean noise, export point clouds, create meshes and textures, and check the scale. We keep a high quality master and a lighter copy for the web. Integration, we add everything to our database with fields for provenance, condition, date, and references. Dissemination, we publish selected models online, make short videos, and prepare 3D prints for handling. And feedback, teachers, curators, and colleagues test these outputs. Their comments improve our next field season and our explanations. Lima Lima Cave is on Byers Peninsula, Livingstone Island. It's an early 19th century sealing site. The cave is dark and complex, so LiDAR is the best method. We made several scan stations to cover all corners and overhangs. The result is a dense and accurate point cloud. In the lab, we registered the scans, removed noise, and exported a clean model. We also produced a watertight mesh for interpretation. With this model, we make sections, measure distance and volumes, and study the occupation floor. We can also compare future scans to detect the change and impact. The model connects to our excavation records. A simplified version supports a VR experience that puts the viewer inside the cave and tells a clear story about labor, shelter, fuel, and material choices. From our meshes, we create teaching kits that people can touch. We choose a scale that keeps important details. We separate the model into logical pieces, like walls and small areas. We print in PLA with simple settings. After printing, we sand, prime, and paint with matte colors, and we add an epoxy coat to resist heavy use. We made portable kits for schools and larger pieces for museums. We printed several versions of Lima Lima Cave and other sites. These replicas create curiosity and longer attention, because people can hold the Antarctic landscape in their hands. We import our models into Unity and build a simple VR walkthrough for MetaQuest. To keep comfort, we bake lights, use occlusion culling, set levels of detail, and offer teleport with snap turning. We also limit the number of draw calls to keep a stable frame rate. In the scene, short prompts connect what the person sees with the evidence. We mix field notes and soundscapes like wind. Users remember spatial relations and task sequences better than with photos alone. For people without a headset, the same models are available on the web. All assets link back to our database, so every claim is traceable. We work with conservation first mindset and follow the Antarctic Treaty rules and national permits. Digitization reduces physical contact and reduces repeat visits to fragile places. Our lessons are simple. Digital methods are not only for outreach, they create new measurements and new questions. Tactile learning with replicas improves engagement and memory. Interactive media gives space for more voices and more types of work. One careful capture can serve research, monitoring, teaching, and public dialogue. Next, we plan repeat LiDAR and photogrammetry at key sites, including Lima Lima Cave. This helps us measure erosion, frost heave, and visitor effects. We will improve links between data, models, photos, and documents will connect through stable web addresses and simple linked data fields. We will expand our teachers' pack and bilingual materials, and we will grow our replica kits for classrooms and museums. We thank LEACH UFMG, ARISE FURG, our partners, and our students. Our goal is clear. Use digital methods to preserve, to analyze, and to invite the public to read and discuss Antarctica's human history. Thank you very much.